Hello, everyone. Hello, supervisor. My name is Xu Pengfei. Today, I'm ready to share my research project. The project is titled Research on Credit Card Fraud Prediction based on Machine Learning. Let's start with the problem. Credit card fraud is a huge issue, constantly changing. Scammers use new tricks all the time, making it hard for old systems to keep up. We have millions of transactions daily, so fighting fraud is like finding a needle in a haystack. Also, if we flag a normal transaction as a fraud, that's bad for customers and the banks. So, what's my solution? Machine learning. It can analyze past data to find unusual patterns, even new ones that traditional systems miss. It's about proactively catching fraud. Go on. What's my goal? My main goal was to figure out how machine learning can fight against these changing fraud missions. It's not just about catching old tricks, but new ones too. Specifically, I wanted to first test out different machine learning models for fraud prediction. Second, find out which factors are most important for predicting fraud. Third, compare how well these models perform to find this best one. And finally, give practical advice to banks on using machine learning for fraud detection. Now, let's talk about how I did it. I used a quantitative approach with machine learning. My data came from Kangol, a synthetic dataset that mimics real credit card transactions. It has anomalous features and a target variables showing if a transaction is fraud 1 or not 0. Before using the data, I cleaned it up, filled missing values, scale filters, and converted data types. This makes the data ready for the models. I also did some exploratory data analysis to understand the data's structure. A big challenge was imbalanced data. Fraud transactions are very rare. To fix this, I used a technique called SMART. This generates new samples for the fraud class, balancing the data set. It helps my models catch more fraud, improving recall and F1 score. I tested 5 supervised machine learning algorithms. First, logistic regression is simple and helps me see the probability of fraud. Next, k-nearest neighbors. It classifies new transactions based on their closest neighbors. Then, sport vector machine. It finds the best boundary to separate fraud and no fraud. It also uses extreme gradient boost, a powerful and efficient boosting algorithm that's great for imbalanced data. Finally, and most importantly, random forest. This builds multiple decision trees and combines their results. It's very accurate and avoids overfitting. All models were trained and validated using cross-validation to ensure their robustness. To check how well my models performed, I looked at several metrics. Accuracy tells me the overall correct predictions, but for fraud, where fraud is rare, it can be misleading. Precision is about how many of my fraud predictions were actually fraud. High precision means fewer false alarms. Recall tells me how many actual fraud cases equals. High recall means I don't miss mass fraud. F1 score, balance, precision, and recall, which is great for imbalanced data like ours. AUC and ROC measures the model's ability to distinguish between fraud and no fraud, even when fraud is real. I also used a confusing matrix to visualize true positives, false positives, true negatives, and false negatives. Let's look at the results. This table summarizes how each model performed. You can clearly see that Random Forest was the winner. It achieved perfect score across all metrics. 100% accuracy, precision, recall, F1 score, and AUC ROC. This means it perfectly identified both fraud and legitimate transactions with almost no errors. The ROC curve graph also shows Random Forest curve. The red line is right up in the top left corner, indicating its excellent performance. To show you Random Forest power more clearly, here is ROC curve and confusing matrix. The ROC curve for Random Forest is almost perfect, with an AUC close to 1. This again shows a strong ability to distinguish fraud from no fraud. And the confusion matrix for Random Forest is also great. It shows very few false negatives and false positives. This means it's super reliable for real-world fraud detection. So, what did I learn? Machine learning, especially Random Forest, is a reliable way to detect credit card fraud, and handling imbalanced data, like with smart and good data preprocessing, are key. But there are some limitations. First, I used a synthetic dataset. It might not capture all the complex fraud patterns in the real world. Second, the models are a bit of a black box. It's hard to explain why a transaction was flagged as fraud, which can be an issue for trust and regulations. Third, I didn't do real-time testing. In rollbacks, models need to process transactions super fast. Finally, I had limited feature engineering because the data was anonymous. I couldn't create more effective features based on specific domain knowledge. Based on my findings, here are some recommendations for future research. First, use real-world data. This will help validate the models in more complex scenarios. Second, explore deep learning missions. They are great at finding patterns in transactions sequences. Third, integrate explainable AI. This helps us understand why a model makes a decision, with building trust and meet compliance needs. Fourth, do real-time deployment evaluation. We need to make sure the model works fast enough for live transactions. Finally, use advanced cross-validation techniques for most generalized results. To sum up, machine learning is crucial for finding credit card fraud. With further improvements and real-world testing, these techniques will be a huge asset for financial institutions. Thank you for your listening.